In the review of the hypertension by gender problem, I noticed a few mistakes going through it, so this will be a good opportunity to review this. All right, so let's take a look. It has been found that 26% of men 20 years or older suffer from hypertension, and that 31.5% of women are hypertensive. Now, they're telling us a random sample of 150 of each gender were selected from recent hospital records, and the following results were obtained. Could you conclude that the higher percentage of women have higher blood pressure? Here's the thing. Part of statistics is reading comprehension. You gotta figure out what you need, what you don't. They're telling me here about the random sample of 150 of each gender was selected and the following results were obtained. And then they're saying, can we conclude that higher percentage of women have high blood pressure? This is the important stuff right here. Random sample of 150 of each gender. And then the following results were obtained right here. And then we're trying to obtain the see if women have higher blood pressure. All this stuff at the beginning, you don't need it. It's just kind of a preface. They're kind of giving you a little introduction here. So part of this is trying to figure out what you need and what you don't, okay? Now, your hypothesis tests are always going to be based on some sort of sample or experiment. So the second they start talking about a sample or an experiment, then your ears should perk up. Okay, I need this. Now, remember, if you're comparing two populations, like what populations are we comparing here? Men and women. We're comparing two populations. That means our null and our alternate, right? Our null is definitely going to be equals each other. P1, we'll say P of men equals P of W, P of women. They're going to equal each other. Or you could set it up like this. Sometimes people will do it like this. P of W minus P of M equals 0, because if they're the same, you're going to be getting 0. You're not testing a specific value when it's a two-sample test. You don't want to have like P of M equals 0.315 or P of W equals 0.315. This is a two-sample test. The only number you really are concerned with here is 0, okay? So that's what we're going to start with our null. You could have either of these. P of M equals P of W. That's the one I personally prefer. Some people like to set it up like, if you subtract the two proportions, you get 0. Either one of those is fine. Now for our alternate, we're trying to prove that women have a higher percentage. So I could say P of M is less than P of W. That's one way of setting it up. I could also say P of W is greater than P of M. Both of them are saying the same thing, that women have a higher proportion. Now, if I want to do it using a similar format to what I did here, I can do that. It just takes a little thinking. Sometimes that extra step throws people off. Now, if the proportion of women was higher than the proportion of men, you subtracted those numbers, think about what would happen here. If the first number is larger than the number that you're using for the second one, you get a number that was greater than 0. So either one of these would work for your alternate. I'd probably prefer going with this one here or this one, but some people prefer going with the PW minus PM is greater than 0. You can do that too. There's nothing wrong with that. Okay, so how are we going to set this up now? Now, here's the way I suggest it. First of all, you want to check your conditions. Always check your conditions. And if it's based on two populations, that means you got to check each condition twice. If you're not doing that, then something should be going off. First condition I'm going to check, random. And I'm going to put a check mark because you know why? I'm going to draw a nice little arrow. Random sample of each gender. That's enough. I'm establishing that it's there. I can't just put a check mark and say done. That little arrow, and plus the fact that I highlight it, indicates that I know that I have two random samples of each gender. It says a random sample of each gender. That's important. Next, I want to check my 10% condition. All right. So it says I get 150 of each. So let's see, 150. I can safely say that that's less than a tenth of all women at that hospital. And you notice I have the calculator off to the side. I figure I want to keep it there so you guys can see the functions I'm using, because I think some of us might be using the wrong calculator functions. just going to zoom in here. 100 of all women at that hospital. So that looks pretty good, but I'm not done. I also have to check that 150 is less than, again, I could do or equal to, of all men at that hospital. I think that is safe to say. All right, so I've got my 10%, I've got my random condition checked, and I've got one more, my large counts. Large counts, if you're doing it based on two populations or two proportions, you need to have 4 checks going on here. If you only have 2 checks, you've done something wrong. So large counts, let's check. They said 43, so we'll start with men. 43 had high blood pressure. Is that greater than or equal to 10? Yes. Now, it's out of 150. So I have to say 150 minus 43. I have to check the ones that don't have high blood pressure. I can safely say 150 minus 43 is greater than 10. I'm okay here. For women, you have 52 patients. Okay, so I'm going to check that out. 52, greater than or equal to 10. Check. Now, I'm not done. I check that the women who don't have it, excuse me, it's also greater than or equal to 10. Guess what it is? I've checked my conditions. That's important. If you're only doing a quick check and you're not doing it for each of your proportions or your populations, you're doing it wrong. I promise that cough is based on a little piece of carrot I ate. It is not anything more. All right, so here's what I'm going to do. This is the way you should be doing it. You get a little hairy if you want to draw it out. I saw some people doing normal distributions. It gets hairy. You haven't gone over the formula for that. So if you're doing that, you're doing something wrong at this point. What you can do, you have your TI, you're going to click Stat. You're going to go to Tests. And you're going to go to 2-prop z-test. Why? Because it's based on 2 proportions. Okay, so out of my first proportion, we'll call that the men. We've got 43 out of 150. For our second, the women, we'll do 52 out of 150. Okay. Now here's where it gets tricky. Now I've established that my first proportion is going to be men, and that my second is going to be women. I'm not trying to prove that there's not equal. I'm not necessarily just trying to prove that there's a difference. I want to prove here, I'm going to go to the second one here, that P1, the men, is less than P2, the women. So you want to make sure you're using the right inequality. If not, you could get a wonky p-value. So this is all the information I need. I'm going to calculate it out. And you notice I get all my important information here. This is what I want to be writing down. I want to write that I did a 2-prop z-test. That's important because if you're just writing down random numbers and p-values, we have no idea where they came from. 2-prop z-test. And then I'm going to write down my critical z, that's important, or my test statistic rather, negative 1.117, and my p-value. These are the 2 important things we need. 0.132. All right, we established the significance level of 0.05. So let's see, 0.132. That is greater than our significance level of 0.05. If we're getting a value greater than our significance level, that means we have failed to reject our null hypothesis. So I can say, since our p-value, excuse this, I have to use a bad stylus here. My other one makes a lot of noise when I'm making a video. Oh, gosh. I'm just going to type it up. Down here. Since our p-value is greater, I thought I'd have better luck. It's okay. Is greater than our significance level, we fail to reject our null hypothesis. I'm not done yet, though. You can't just say that. You need to put it in the context. So since you failed, you do not have enough evidence to prove that women have I've established this now. Good. And I love how some people even took this a step further. They said, what kind of error could have occurred? If you failed to reject the null when you should be, that's a type 2 error. This could be an example of a type 2 error. Remember, reject the null and the null is true. That's type 1 and not type 2. We didn't reject the null here. We could have failed to reject the null when we should have, and that could be a type 2 error. But you don't even have to go that far. So again, let's take a look at these steps. First of all, if you're comparing two different groups of people, two different groups of things, that is a 2-prop z-test, or it might be a 2-sample t-test. We're going to get into those later, but for right now, if it's dealing with proportions, it's a 2-prop z-test, which means your null has to look something like this. If you're throwing in another number that's not 0, you're doing something wrong. Either set them to equal each other, or set them that if you subtract them from one another, you're going to get an answer of 0. And then for your alternate, it's either going to be some sort of inequality, or if you're trying to prove that there's just a difference, it's just going to be doesn't equal. And then the calculator function, before we do that, your conditions, remember, you have to check it for both groups. If you're just doing it for one group, you did something wrong. If you're combining them all into one group, you're doing something wrong. And then we want to run a 2-prop z-test. Again, on your calculator, stat, go to 2-prop z-test. And then you would enter in all necessary information, just like we did, to get your p-value and your test statistic. Those are the 2 important things you want to write down. And then based on your p-value, you write a conclusion that includes the context of the problem. Because that's what we're ultimately looking at here. Numbers are okay, but in statistics, it's all about context. We want to see how this applies to our situation. So if you made any mistakes on this, please, fix them, use this video as a guide. And if you have any questions, if you're one of my students, you can reach out to me at my school address. If you're not a student of mine, you can reach out to me at